Example 17. This is a bouncy ball, and it's going to be an example of a word problem or a real life problem that we can use the formula for adding up the sum to infinity of a geometric series. So sum to infinity. So a bouncy ball is dropped straight down from a height of 1.5 meters. Okay, so I'm going to draw the situation. We've got a bouncy ball and it's dropped to the floor or the ground 1.5 meters. Okay, and it bounces. So it hits here and it bounces up. With each bounce, it rebounds 75% of its height. Okay, so that means that R is going to be 0.75. So 75% of the height of 1.5, for example, would be 0.75 and half of that. So 75%, actually, let's just figure it out so we can see, for example, what those numbers look like. So 1.5, oops, no, I don't want to calculate, okay. 1.5 multiplied by 0.75, so that would be 1.125, that next piece. It's going to bounce up that far, 1.125 meters, and then it's going to travel that amount again, 1.125 centimeters when it bounces down. Then it's going to come up 75% of that, which is 0.84, 0.84375 meters. And it's going to bounce down again, that amount, and then it's going to keep on doing that, 75%. And in theory, infinitely. But the point here is I'm showing that we have this distance to begin with, and then it bounces up, but then bounces down. So that distance, and this distance, and this distance, and this distance, and on and on and on. All of them are going to be doubled except that first one. So here is the exact same distance. Here's the exact same distance as the red. Here's the exact same distance. Okay, so it's going to be actually twice as much as what we end up calculating. So let's see. We're going to sum it to infinity. So U1 divided by 1 minus R. U1 is 1.5. R is 0.75. So we're doing 1.5 divided by 0.25, or divided by a quarter, which is the same as multiplying by 4. So that should be 6. So 6 meters. Okay, but what does that 6 meters tell us? It tells us those red distances. Okay, the red distances. That 6 meters is all those reds. Now we also need to add all the blues. Okay, so the blues are greens. So we would double this. Okay, so double it. But if we double it, so 6 times 2, 12 meters, that means that this first one was also doubled, 1.5. So now we have to take away that 1.5. So 12 subtract 1.5 is 10.5 meters. And that there is your answer to this question. What is the total distance it travels until it comes to rest? So we used the sum to infinity. We figured out what R is for that. Calculated 6 meters. But from our diagram, we can see that that actually only takes into consideration adding up all those red distances. We also have all the ups to do. So we could double it, but we started up here with the ball. So the first distance is not doubled, so then we take away that first distance. Our answer, 10.5 meters.